Math 3, Unit 10, Section D, which goes along with Worksheet 4. One thing before we start today is I want you to remind yourself that anytime you take a square root, your answer is what? Good, plus or minus, positive and negative, which means there's actually two answers, okay? So this first one is asking us, when is sine less than 0? Okay, first of all, we need to remember that cosine is dealing with your x or y, x, and sine is dealing with our y. And so when it's saying when is sine less than 0, we're talking about sine being what? Sine being negative, which means that when is y negative? Okay, so if you're looking at your quadrants, y is positive up here, and so when is sine negative? Which quadrants? Quadrants 3 and quadrants 4. Okay, on this next one, it says tangent squared is less than 0. Okay, and so first of all, this is telling us because it's being squared, okay, our answer could be what? It can be positive or negative, because when you square something, if it's positive, it's going to square and become a positive, right? And if you have a negative and when you square it, it's still going to become a positive. So what this is saying is a positive is less than 0. This one, if we go back and write, it's just a negative is less than 0, okay? Can a positive ever be less than 0? No. So this one would be undefined or no solution. We'll go ahead and just write undefined. And if you want to make a note to yourself, okay, a positive cannot be a negative. Okay, are we good? Does that make sense? So this is basically saying if you were to take any value for tangent and square it, it will always end up becoming a positive. Okay? Because when you square something, whether it's negative or positive, it will always become a positive, and a positive cannot be less than 0. That doesn't work. Yes? Okay. All right. These next parts, there are triangles here for you where we could have filled in this information, but ultimately we have our unit circle that we made, correct? And so we're going to use this throughout our notes today, okay? It's going to make your life way easier. Okay, so first example, they want us to solve for all values of theta such that the degree is in between 0 and 360, okay? So what we want to do is get sine by itself. What would I do first in order to get sine by itself? Nope. Add 3 first. Good. Add 3 to both sides. Okay. So we get 4 sine squared of theta equals 3. What will I do next? Very good. Divide by 4 to both sides, because ultimately you're trying to get your sine, cosine, your trig function by itself. So sine squared of theta equals 3 over 4. Okay, because I have sine squared, what am I going to do? Good, I'm going to take the square root of both sides. So, and I'm just going to write this as a square root of everything. So this ends up being that sine of theta equals plus or minus root 3 over, what's the square root of 4? Square root 2. And we don't need to have plus or minus on both the top and the bottom. We're just saying this number will be plus or minus because I took the square root. Okay, Now, sine is dealing with what trig function, or what letter, x or y? Okay, so we are going to go to our unit circle and figure out which values, which degrees give me root 3 over 2 for the y value. And now on this one, it can be positive or negative. So that means there is probably an answer in every single quadrant, right? Because sine is either positive or negative in every trig or every quadrant. Okay, so sine is y. In the first quadrant, where is y root 3 over 2? 60 degrees. Does everybody see that? Here the y value is root 3 over 2. Okay, so that means 60 degrees is one of our answers. We're trying to find what degree this is. Does that make sense? We're finding what theta is. And so theta could be 60 degrees because at 60 degrees, the y is root 3 over 2, and sine is dealing with y. Okay? Over here, which degree is y root 3 over 2? 120. Okay? In quadrant 3, where is y root 3 over 2? 240. And you notice that there's other root 3's over 2's, right? So you have to be careful that you're looking for the one that's in the y spot. And see how this is in the y spot. That's 210 degrees. And then in quadrant 4, where is y root 3 over 2?
300.
Good, 300 degrees. Oh, thank you. Yes, perfect. Okay, so those are our answers for the first one. Okay, does anybody want to ask me questions or anything on that? Okay, no questions? Okay, so same thing here. We want to get our trig function by itself. So first thing I'm going to do is, good, add 5 to both sides. I have 10 cosine theta equals 5. What will I do next? Very good. Divide by 10 to both sides. And I get cosine of theta equals, good, 1/2. Now, am I going to take a square root here? No. So cosine is positive, and so I always kind of like to write this down. We know that cosine is dealing with what? X or y? X. Okay? And remember how I remember that is, it comes first in the alphabet, right? C comes first and so does X, so cosine and X go together. Okay, so when is X positive? Which quadrants? 1 and 4. Good, 1 and 4 is correct. So that means we're finding where is X 1/2 in only quadrants 1 and 4, because that is where it is positive. Okay, so where is X a positive 1/2?
60 degrees.
Good. 60 degrees and 300 degrees. So those are my answers. Okay? Questions? So everybody understands where we're getting these numbers? Okay. Next example. What will I do first? Good. We have 2 tangent squared of theta equals 6. Next step will be to do what? Very good. So these cancel. I get tangent squared of theta equals, good. Okay, what will be my next step? Very good. Take the square root of both sides. So when I do that, I'm going to get tangent of theta equals what? Close. We're going to do plus or minus root 3. Okay? Now we can think of this, actually though, we can make this into a fraction and it can be root 3 over what number? 1. Okay. Everybody good with that? Now this is one where it takes a little bit more thinking. First of all, we know that tangent is what in terms of x and y? Very good. y over x. So we are trying to find where is y root 3 and x1. And because it's plus or minus, we can go to every single quadrant because it's plus or minus, okay? So we're only looking though, because remember the bottom number is like your hypotenuse or your radius. And so we're looking, so whenever we have like these x values and y values, it's really like your x or y value over your hypotenuse or radius, okay? And so we're not looking at our denominators, we're only looking at the numerators for these numbers. So starting in the first quadrant, which one has it as y being root 3 and x being 1 in the same ordered pair? So again, and if you need to by here, y is our root 3 and x is the 1. So in our first quadrant, which degree would it be?
60.
Very good. 60 is correct. Okay, so then we'll go over to quadrant 2. So again, we're looking where y is root 3 and x is 1. What is it?
150.
120. So see, always look at x and y. So y has to be root 3 and x has to be 1. And since it's plus or minus, it doesn't really matter, right? In terms of which one's positive and which one's negative. Okay, so 120 degrees. Okay, in quadrant 3, where is y root 3 and x 1?
240.
Good. And again, do you notice that we're not looking at the bottom value because that's like your radius or your hypotenuse? So this is representing our x, this is our x, and this is representing our y. Is that better?
Yeah.
Okay. So then in quadrant 4, which degree has y as root 3 and x as 1?
300.
300. Oh, and I put 2, sorry. 300 degrees. Okay, so those are our answers. Questions? We're okay? All right. On this next one, notice that it's been factored, okay? Which is fine. All we're going to do is set up, it's basically just saying that there are 2 different equations in this actual problem. So we're just going to split it up, okay? So that means one problem is going to be root 2 cosine theta plus 1 equals 0. And then the other one will be 2 sine of theta minus 1 equals 0. Okay, so we're just going to solve both of them. Okay, on this first one, what am I going to do?
Subtract the 1.
Subtract 1. And we get root 2 cosine theta equals negative 1. Next step, I'll do what? Good. Divide by root 2. And so I have cosine of theta equals, and is this an acceptable answer?
No.
No.
It's negative 2 over 2.
Very good. It'll be negative root 2 over 2 when I rationalize the denominator. And everybody's okay with doing that in our heads? Okay. What quadrants am I going to be looking at here? When is cosine negative? And again, remember, we know that cosine is dealing with x. And so when is x negative? 2 and 3. So we're looking for where is x? Negative root 2 over 2, which will be, we know, in quadrants 2 and 3. So where is x negative, what am I doing? Hold on. Yeah, negative root 2 over 2. Good, 135.
250.
Very good. And then 200, and not 15, 225, right?
Oh, I didn't know.
Okay, everybody okay there? All right, so over here, what are we going to do? Add 1 to both sides. We get 2 sine theta equals 1. Next step would be to, good, divide by 2 to both sides. I get sine of theta equals 1/2. So we know that sine is dealing with y. Where is y positive? in quadrants 1 and 2. Good. And so we're going to go to quadrants 1 and 2 and look where y is positive 1/2. So what degrees?
30.
30 and
150.
very good. 30 degrees and 150 degrees. And so these are my answers for this problem. Okay. Moving on to the next one. Okay, so same instructions. We're going to go ahead and go through on this one. First thing I would do is subtract 2 root 3 to both sides. These cancel. I get 6 tangent of theta equals negative 2 root 3. What do I do next? Good. Divide by 6 to both sides. We have tangent of theta equals, and we have to reduce. So the 2 cancels out, and 2 goes into 6 3 times. So I have negative root 3 over 3. Now, tangent is a little bit different, remember, because we know that tangent is actually dealing with y over x. Correct? On this one, hopefully you can tell because you have a root 3 over 3. If you had a root 2 over 2, you know it's been simplified, correct? And so because we need this to our original y value and our original x value, we want to undo the rationalization here. Okay, so if this was not rationalized, what would it actually be? The root 3 would be on the bottom, and what would be on the top? Good. Are you guys okay with this? Okay, so we are looking for y being 1 and x being root 3, and either one of them could be negative. Now, for instance, remember in our quadrant thing here, where is tangent going to be negative? Which quadrants?
1 and 3.
Close. 2 and 4 is where tangent is negative. Because remember, you're dealing with y over x. This one is negative, negative, and so that would make a positive. These 2 are positives, so those 2 are negatives. So we're looking in quadrants 2 and quadrants 3. Okay? And so where is in quadrant 2?
Isn't that quadrants 2 and 4?
Yes. Thank you. Okay. Where is y1 and x root 3? 120, right? Do you guys see that? So y, oh wait, no, we're not doing that. You guys said it right. 150 is correct. Y has to be 1 and x has to be root 3. So do we see the difference between these two? Okay, so the answer on quadrant 2 is 150 degrees. What is the answer in quadrant 4? Which one?
330.
330 is correct. Okay, and again in 330, the y is 1 and our x is root 3. And notice that just one of them has to be negative in order to make tangent negative. Okay. Next one. What will I do first? Good. Subtract root 2. These cancel. We get 2 sine theta equals negative root 2. Then I will do what? Divide by 2 to both sides. And so we have sine of theta equals negative root 2 over 2. Now this one, we can see that it's been rationalized, but the only one we need to change is tangent, because we actually want sine to be rationalized. Sine is dealing with the what? The y. Okay, so when is sine negative? When is y negative? Which quadrants? 3 and 4, right? So where is the y negative root 2 over 2 in quadrant 3? Very good. 225 is correct. And where is the y negative root 2 over 2 in quadrant 4?
315.
Very good. 315. And so there we have our answers on that problem. Okay, questions. Do you guys feel like it makes sense? Pretty easy? Okay. Last one. This one is slightly a review, a little bit. This tells us that the cosine of C equals 4 over 5. And they want us to find the perimeter and the area of this isosceles. So first of all, when it says it's an isosceles triangle, what is it telling us? Actually, more specifically, it means that these two sides are the same. Okay? And if I were to draw a perpendicular line down, this would make this a 90-degree angle, and it would cut the bottom in half, making this side 21 and this side also 21. Okay. Now, because it's saying cosine of C is 4 over 5, if we go to C right here, that means we know that cosine is what over what? Adjacent over hypotenuse. So it's saying that this is 4 over, oh, you know what? I think that, oh yeah. Okay, 4 over 5. So it's saying that this side is 4 and this side is 5. And I actually think that I made a slight error in that I wanted this to be 3. So if we can change these to 3s, I will fix this in my notes for next year. Okay, so we're actually going to say cosine of C is 3 over 5. Okay, now if this is 3 and this is 5, do you guys know what kind of triangle this is? It's actually a 3, 4, 5. And you could end up going like 3 squared plus b squared equals 5 squared to find out that this one ends up being a 4. Okay? So 9 plus b squared equals 25. You subtract 9. We get b squared equals 16, which means that b equals 4. Now, this side is not actually 3 though, it's 21. And so it's dealing with your proportions. Okay, so 3 times what makes 21? So that means we would go 4 times 7, which makes this side what? 28. Okay, and then 5 times 7, which would make this side 35. And so if you're doing your perimeter, okay, we have 35 plus 35 plus 42. Because we know the whole base is 42. You add that together and your perimeter is 112 units. Area, how do you find the area of a triangle? Base, so on this one our base is 42 times our height, which is 28 divided by 2, however you want to write it. Okay, and then we reduce and we get 21, and 21 times 28 is 588 units squared. Okay, any questions?